This is Chelsea, and this is Lab 5, Objective 1. So in this objective, I have an LED and a 550 ohm resistor. And in this lab, I'm gonna talk about using analog write function on my Arduino sketch. So I have the resistor going to ground, and from there I have this black jumper cable going to ground on the Arduino board, and then I have the LED being connected to channel 3 on the Arduino. So when I put this in, it should look something like this. So when my sketch looks like this, and it's just a basic sketch, so it says void setup, pin mode, 3 outputs. So it's setting the LED as an output device, and then you come down to void loop and it uses analog write LED 127. So that's saying that it lights the LED at a various brightness by changing the value. So if I change the value to like 255, which is the highest value, and I re-upload it, the LED then should get brighter. It turns off and it gets brighter. But if I put it to, let's say, 64 or 65, upload it, the LED gets dimmer. And do another example. Let's say I put it down to 15. So that's the function of analog write. Let's say I hook up the circuit to an oscilloscope, and then I type in 50 on my Arduino sketch. The oscilloscope would look half on and half off. That means the 50 is half of 100%, which is putting out 2.5 volts instead of 5 volts. The 5 volts would equal the 100%, and 2.5 equals the 50%. This is objective 2, which means it's using half of its duty cycle. So in this objective, I have my potentiometer, my DC motor, and my 9-volt battery, which is my power supply. So from there, I have the red going into the red lead, and the black going into the ground. From there, I have the red lead going into one side of the potentiometer, through the potentiometer, through the motor, and then out from the motor comes the ground, and then through the ground it goes back into the potentiometer. So in this case, I'm going to turn up the potentiometer to turn my motor on, and this will give me a variable voltage of how fast the motor is going. And then the current on here, when the potentiometer is turned all the way up, the current will be 100 milliamps. So I turn it all the way up, it'll do this, and it'll look like that. And if I were to put my finger on it and put an ohm meter across the circuit, the current will go up if I put my finger on it. But if I don't put my finger on it, the current will be 100 milliamps. This is objective 3. And in this objective, I have a 9-volt battery still, my DC motor, a potentiometer, a diode, transistor, and I'm going to use the potentiometer to help vary the speed of the DC motor here. So it's safe to say that this potentiometer is a separate circuit from this over here. And so my sketch will look something like this in Arduino. So it's initializing the potentiometer, and in void setup it's setting the motor as an output, and then in serial begin it'll start serial communications. Down here in void loop, it delays for 1 second, and then potentiometer, this is pretty much analog read is reading the potentiometer as an analog input, and then this communicates with the serial communication, and if I open up the serial communication, it'll actually show me different values if the motor is on or off. And analog write is pretty much just using the potentiometer as an input to the motor. Okay, so what I have here is the battery. The red cord goes in the red lead. Then I have the red cord for the motor, which then goes through the motor back to ground, through the orange jumper cable, through the transistor, back to the motor, and then through the diode, and then through the Arduino circuit so I can pick up the circuit, and then back to ground. So when I turn on my battery here, and I turn up the potentiometer, so this is a low speed. Now to keep turning it up, it's a high speed, and it'll look like this. And this is the varying speed of the potentiometer. You can hear it slowing down. Eventually it's off. And if I open up my serial monitor here, now it's displaying that the motor is off. If I turn it up, it gives me different values of the voltage going through the motor. Okay, this is objective 4. In this objective, I have the same setup as objective 3, but I added a push button, which is here, and a 220 ohm resistor, or no, a 10k ohm resistor. And what it's going to do is, when the potentiometer is at a certain value on Arduino, if I have the potentiometer set to 500, the motor's still going to be off, but when I push the button, the motor will turn on. So my sketch would look something like this. So I have if-else statement. If button 1 state equals low, so that means this button will be pushed, and the potentiometer value has to be at 500. And then when I put it in serial monitor, right now it's reading 630, so the potentiometer is above the value. So when I push the button, the motor starts running. If I turn the potentiometer down or below 500 and push the button, it doesn't come on. And that completes the circuits.